This video is demonstrating experiment 10 from Advanced Chemistry with Vernier entitled The Determination of an Equilibrium Constant. Today we're going to be determining the equilibrium constant between a reaction of iron 3 ions and thiocyanate ions. The net ionic equation is shown here. We're going to be determining the equilibrium constant, or KEQ, with this equation. To determine the KEQ value, we're going to have to figure out the concentrations of all of the species at equilibrium. To get those concentration values, we're going to be measuring the absorbance of each of the species using the Vernier svis-pl spectrophotometer. This experiment will take 3 parts. Part 1 investigates a series of iron thiocyanate standards where we vary the thiocyanate ion but keep the iron concentration constant and have an excess concentration of hydrogen ions. It does take about 1 minute to form the complex, and it does start to decompose after about 4 minutes, so time can be an issue with this experiment. Part 2, we're going to analyze a sample with an unknown thiocyanate concentration. And finally, part 3, similar to part 1, is to investigate a series of standards, this time keeping constant the hydrogen ion while varying the iron and thiocyanate ion concentrations. So prior to this, I prepared all of my samples and did all my pre-lab calculations. So I'm actually ready to take data. The svis-pl plugs in directly to the LabQuest 2 via USB. Once I've plugged it in, I should see this screen with a nice big red box that says absorbance, and the mode should be full spectrum. Before collecting any data, I need to make sure I've warmed up my lamp and I've also calibrated. So in order to calibrate, I tap on this red box and tap on the calibrate button, and a separate screen should come up. It will automatically begin counting down the 90 seconds for warm-up, and I want to make sure I have my blank ready to do the calibration. The blank in this particular experiment is very important, that it is not water, that it actually contains some of the iron solution as written out in the experiment. Make sure the clear sides of the cuvette follow the path length that is indicated by the arrow on the spectrophotometer. Make sure you've waited the full 90 seconds for the lamp to warm up before you begin the rest of the calibration procedure. Then to finish the calibration, make sure that you have your blank cuvette in the spectrophotometer and tap on the Finish Calibration button. It will take a few seconds to complete calibrating, and when it's ready, you will be able to tap on the OK button. And now we're ready to take a full spectrum of one of our samples. Pick any one of your samples and put it in the path length. And then we're going to tap on the Collect button. The graph screen should automatically show up, and you should see the full spectrum. I will have to press stop once I've seen the full spectrum, and it will automatically pick the peak that has the highest absorbance value for me, which is around 452 nanometers. This is the wavelength that I want to use to determine the absorbance values for all of my samples. So to set up for that, I need to change the mode to events with entry. So I go back to the meter screen and tap on the Mode button. From the drop-down menu up here, I need to select Events with Entry. My event in this case is concentration, so I'm going to abbreviate it CONC, and my units are going to be in moles per liter. Select Done, and once I've typed in all that, I can select OK. I'm going to go ahead and discard the data, but you can save it there so you can have a full spectrum saved for your lab report if you wish. So now it tells me up here exactly what wavelength I'm reading at. If I wanted to investigate the samples at a different wavelength, I would simply tap on the red box and tap on Change Wavelength. Now that I'm in Events with Entry mode and will be typing in each concentration for each sample, I'm going to go ahead and press the Collect button, and I see this second button that says Keep. When I'm ready, when I've put my sample in and this absorbance value up here has stabilized, then I select the Keep button and type in the concentration for this particular sample. Select OK, and there is my first data point. Then I'm going to switch to my next sample. Make sure I watch the absorbance value in the corner to make sure it's stabilized before I tap on Keep again. And then I type in the concentration for this sample. And I'm going to repeat this process for each of the samples that I have. I want to make sure that I do my blank. And then once I've done running through all of my standard samples, then I tap on Stop. And now I have a very nice linear line for all of my samples. For part 2, we're going to analyze an unknown sample that I've prepared. And to do that, we want to take the data we collected in part 1 and fit a linear equation to it. Now to do that, from the Analyze menu, we select Curve Fit, and then select the data. From the Fit Equation drop-down menu, we want to select Linear. And you can see right away the line that's fit to the data. Then select OK, and all that information is on the right side of the screen here. So we have a very nice Beer's Law equation. When I go back to the meter screen after I've inserted the unknown sample into my spectrometer, it's reading the absorbance value of my unknown. I take that absorbance value and plug it into my Beer's Law equation that I determined in part 1, and I have the concentration for my unknown. In part 3, you're going to investigate a different set of standards, just like we investigated the standards for part 1, where you get absorbance data versus concentration in a Beer's Law linear graph. To then calculate the equilibrium constant for the reaction, you plug your values into this equation. If you would like additional information about this experiment or other experiments from Advanced Chemistry with Vernier, visit our website.